Hey everyone, ready for another deep dive?
Always ready.
Well, today we're blasting off with the Voyager 2 mission.
Oh, a classic.
Seriously, over 45 years in space. That's longer than some of our listeners have even been alive.
It's amazing, isn't it?
Absolutely. So for those tuning in for the first time, what makes Voyager 2 so iconic?
Where to even begin? Imagine volcanoes erupting on a moon of Jupiter.
Whoa.
Winds on Neptune raging faster than a jet fighter.
Seriously.
And a message in a bottle for aliens just out there hurtling through space.
Talk about a long shot.
Right. But you gotta admire the optimism.
Absolutely. All right, let's rewind back to the beginning. When did this epic journey start?
Well, it all kicked off in 1977.
1977, wow. Disco was king.
Haha, yeah. But out in the cosmos, NASA had this genius plan they called the Grand Tour.
Okay, the Grand Tour. I'm intrigued. What's that all about?
So picture this. A rare planetary alignment. It happens only every 176 years.
Wow, that's rare.
Right. And NASA seized the moment, designing Voyager 2 to use the gravity of each planet to slingshot itself onto the next.
Like a cosmic pinball machine.
Exactly. It visited Jupiter, Saturn, Uranus, and Neptune.
All in one trip. That's wild.
And here's the kicker.
Yeah?
Voyager 2 is still the only spacecraft to have ever visited both Uranus and Neptune.
Wow, what an accomplishment.
Yeah.
But hold on a sec. 1977, we're talking pre-internet, pre-cell phones. What kind of technology were we even working with back then?
Think about it. Voyager 2 uses 8-track tape recorders to store data.
You're kidding, right? 8 tracks, like what my parents used to have.
Yep, the same tech.
Oh.
And its onboard computer, less memory than a single low-res image on your phone today.
It's mind-blowing that it's still sending us data after all this time.
Billions of kilometers away.
It really puts our modern tech into perspective.
Yeah.
But let's get to the discoveries. What mind-blowing things did Voyager 2 uncover during its grand tour?
Well, each planet was a revelation. Let's start with Jupiter.
No, Jupiter, king of the planets.
Voyager 2 gave us our first detailed look at the Great Red Spot.
Oh yeah, that giant storm.
And when I say giant, I mean it. This thing is so large, it could swallow the entire Earth.
You're serious? I always knew it was big, but that's insane.
Yeah, it puts things into perspective. And that wasn't all. Voyager 2 also discovered active volcanoes on Io,
Io?
one of Jupiter's moons.
Volcanoes on a moon? What?
It was a huge discovery, the first time we'd seen active volcanoes anywhere other than Earth.
So other worlds could be geologically active too. What a game changer. Okay, on to Saturn, the ringed beauty. What did Voyager 2 find there?
Well, Saturn's rings, of course, are spectacular.
Absolutely stunning.
Voyager 2 sent back incredible images, but it also revealed something unexpected. The rings are far more complex than we imagined.
Really? How so?
They have these strange structures.
Like what?
Spokes, braids, things scientists are still puzzling over.
They almost defy gravity.
Exactly. It's like they're being sculpted by some unseen forces.
Okay, that's just creepy. All right, what about Uranus?
Uranus. Voyager 2 was the first and still the only spacecraft to visit that ice giant.
The sideways planet.
Aha! Exactly. Before Voyager 2 arrived in '86, Uranus was a total enigma.
So what did we learn?
Well, for one, it's tilted on its side.
Yeah, like it got knocked over or something.
It has a 98-degree tilt.
An entire planet lying on its side. Crazy. Okay, we've got a giant storm, volcanoes on a moon, mysterious rings, and a tilted planet. What did Voyager 2 find at Neptune?
Neptune definitely saved some drama for the grand finale.
I bet. What did it find?
Voyager 2 clocked the fastest winds in our solar system there.
No way. How fast?
An incredible 2,100 kilometers per hour.
You gotta be kidding me.
Over 3 times faster than the speed of sound.
Those winds would rip you apart. So Neptune is the windiest place in our solar system.
You got it. And just like Jupiter has the Great Red Spot, Neptune has a giant storm of its own, the Great Dark Spot.
So there are patterns in the chaos.
It seems that way. But it was Neptune's moon, Triton, that really stole the show.
Triton. What happened there?
Voyager 2 revealed geysers erupting liquid nitrogen.
Hold on, geysers of liquid nitrogen.
Imagine fountains of nitrogen shooting into the sky.
Okay, this mission wasn't scripted for a Hollywood blockbuster, right? It's got it all. But seriously, how did Voyager 2 even capture all this data? What kind of instruments did it have?
Well, it had a suite of scientific instruments,
I bet.
but 2 that stand out are the plasma science instrument and the magnetometer.
Okay, those sound pretty high-tech.
Imagine the solar wind. this constant stream of charged particles from the sun.
Okay, I'm picturing it.
The plasma science instrument was like Voyager 2's weather station out in space.
Interesting.
It measured the properties of the solar wind, helping us understand this giant bubble that surrounds our solar system.
You mean the heliosphere?
That's it. It shields us from harmful interstellar radiation. Voyager 2 basically helped map the boundaries of our cosmic shield.
Wow, that's crucial.
Right. And then we have the magnetometer.
Okay, the magnetometer. What did that one do?
Think of it as Voyager 2's compass. It measured magnetic fields, both around the planets and in interstellar space.
So it was like mapping the magnetic landscape of the solar system.
Exactly. And those fields interact with the solar wind.
Affecting how much radiation gets in.
You got it.
So Voyager 2 was like a space weather station, giving us insights into the environment beyond Earth.
Exactly. And its data has even helped us understand our own planet's climate better. It's amazing what studying these distant worlds can teach us about home.
It's like a cosmic mirror reflecting back on ourselves.
Well put. You know, it's incredible to think that a spacecraft launched back in the 70s is still going strong.
I know, right? Almost half a century out there. It had to be built like a tank or something.
Well, partly, yeah. The design is super robust.
It makes sense.
But the real secret, its power source.
Oh, what's powering this thing?
It's called a radioisotope thermoelectric generator.
Try saying that 3 times fast.
Yeah. It's a mouthful, right?
Definitely.
People usually just call it an RTG.
Okay, an RTG. What's
Yeah.
that?
It's a type of nuclear battery.
Nuclear.
Yep. It converts heat from decaying plutonium into electricity.
Wow, that's pretty intense.
It's incredibly reliable, though.
I can imagine.
And it doesn't need sunlight, which is super important for something traveling so far out there.
Yeah, that makes sense. It's not like there are many charging stations out in interstellar space.
Exactly.
But still, keeping a 50-year-old spacecraft running can't be easy.
Oh, it's a huge challenge. The NASA team deserves a ton of credit.
For sure.
They've had to come up with some really creative solutions.
Like what?
Well, some components have failed over time, and they've had to figure out ways to work around that.
I bet.
And as power levels decrease, they have to prioritize which instruments stay active.
It's like a cosmic game of Tetris.
Kind of. And get this,
I see.
they've even written software patches.
For a 50-year-old computer system.
Yep. The technology is older than most of the people working on the mission.
Talk about a throwback. That must be like trying to fix a vintage computer.
You could say that, but it's not just about keeping it running. They're
Okay.
still getting incredible data from it.
Amazing.
In fact, remember Voyager 1? Voyager 2's twin.
Oh, yeah, of course.
Well, back in 2012, it became the first human-made object to enter interstellar space.
Interstellar space, the region between the stars.
Exactly. And Voyager 2 followed suit in 2018.
Wow, so both of them are out there now.
Sending back data from uncharted territory.
That's incredible. What are we learning from this interstellar data?
Well, we're getting a glimpse into the density and temperature of the interstellar medium.
The stuff between the stars.
Yep. We're also learning about the magnetic fields out there and the levels of cosmic rays.
It's like a whole new frontier of science.
It really is. And this information is helping us understand the boundary between our solar system and interstellar space.
Which is probably more complicated than we thought.
Oh, absolutely. It's much more complex and dynamic than we imagined.
It's like discovering a whole new continent, but on a cosmic scale.
Exactly. This mission just keeps on giving.
I know, right? It's amazing how something launched decades ago is still expanding our knowledge today.
It really is. And speaking of incredible things on this mission, let's not forget about one of the most fascinating aspects.
You mean?
The golden record.
Oh, yes. The golden record. It's like that message in a bottle for aliens, right?
Precisely. It's this 12-inch gold-plated copper disc.
Fancy.
And it's packed with sounds and images.
What kind of sounds and images?
All sorts. They were chosen to show the diversity of life and culture here on Earth.
So it's like a snapshot of humanity.
Exactly.
Right.
It's designed to introduce Earth to any extraterrestrial civilization that might find Voyager 2 billion of years from now.
Like, what are the chances?
It's a long shot for sure.
Like finding a needle in a cosmic haystack.
You could say that. But even if the golden record never reaches an alien audience...
It's still an amazing idea.
Right. It symbolizes human ingenuity and our desire to connect with the universe.
It's a hopeful message.
It represents our hope that we're not alone and that someday, somewhere, other intelligent beings might appreciate our planet.
It's almost like a love letter to the cosmos.
Yeah.
Right? Like we're saying, hey, we're here. This is us. We hope you're out there too.
I love that. A love letter to the cosmos.
And even if it never finds its intended audience, the golden record is a reminder to us here on Earth
About what?
About the incredible things we could achieve when we put our minds to it.
You're absolutely right. It's a testament to our imagination, our creativity, our curiosity about the universe.
The fact that we even pulled this off is incredible.
I agree.
We've talked about the scientific discoveries, the technology, the philosophical side of things.
A lot to unpack.
But the golden record adds another layer of meaning to the whole Voyager mission, don't you think? It elevates it from just science to something more.
More what?
I don't know, more philosophical, maybe even spiritual.
I completely agree. The Voyager missions, with those golden records hurtling through space, carrying messages from Earth,
It's powerful.
it speaks to something deep within us, our longing to understand what's out there, our search for meaning in a vast and mysterious universe.
Our place in the cosmos.
Exactly. And that's a legacy that will last long after the spacecraft themselves fall silent.
Voyager 2, still out there after all these years. It's incredible.
It really shows you what humans can do, when we set our minds to something.
It's true, we get caught up in our lives. But then something like Voyager 2 comes along.
It really puts things into perspective.
We've talked about the discoveries, the technology, the philosophy.
It's a pretty amazing mission.
It is.
Yeah.
But I'm curious, what's been the most impactful part for you personally? What really sticks with you?
That's a great question. I think for me, it's the sheer audacity of it all.
The audacity.
Yeah, think about it. Back in the 70s, sending a spacecraft, not to just one planet, but to 4.
And then beyond.
Right, into interstellar space. And then on top of that, they put that message on board.
The golden record.
Yes, for some alien civilization to find billions of years from now, it's mind-boggling.
It's a long shot for sure.
It is. But it speaks to our optimism, our belief in the future.
It's like we're reaching out, trying to connect with something bigger than ourselves.
Exactly. And that sense of wonder, that's what I hope people take away from Voyager's story.
It's a story about pushing boundaries.
It's about exploration, discovery.
It's a story that's still unfolding.
Even after all these years.
Who knows what the future holds for Voyager 2?
I know, right? It's already outdone itself.
It really has.
But it's expected to keep sending data for at least another decade.
Wow, really?
Maybe even longer. So we'll keep learning about interstellar space, the boundaries of our solar system.
About the universe itself.
Exactly. And who knows? Maybe, just maybe, someday that golden record will find its audience.
That would be incredible.
It would be the ultimate confirmation that we're not alone in the universe.
We've covered so much in this deep dive.
Yeah.
Any final thoughts for our listeners?
Just this. The Voyager missions show us the power of human curiosity, our drive to explore.
That's a great way to put it.
There's still so much out there to discover, so much we don't know.
It's a vast universe.
So keep exploring, keep asking questions, keep looking up at the stars.
Beautifully said. And on that note, thanks for joining us on this deep dive into the Voyager 2 mission. It's been a journey.
It really has.
Until next time, keep looking up and keep exploring.